Okay, so I'm back for part two. Like I said, we're going to kind of fill in a little bit of this chart here, and then we will do some examples together, just lots of different examples, so you kind of get exposed to different types of problems, okay? So in the table here that we're going to complete, just kind of reviews those properties. So this first one goes pretty quickly because we already talked about anything to the 0 power is simply 1. And we already talked about, or were introduced to, when you have a negative exponent, you've got to flip it. And if your exponent, like I said, is below 5, then go ahead and work it out all the way. So this one, we would go ahead and simplify it all the way to 1/16. And on this problem, since it's 5, I would go ahead and leave it, although technically we could simplify it to -243, but I would go ahead and just leave it as 1 over -3 to the 5th power. Another thing I kind of want to remind you about is the caret. So when you are using your calculator and you have an exponent that is other than 2, you're going to look for this little button here on your calculator. Looks like a upside down V. And this is your calc button that you use to do exponents other than 2. And yes, it will do negative exponents, but a lot of times it will give you the answer in decimal form, and I don't want the answer in decimal form. I want the answer as a fraction. So just be aware of that, okay? So in the first problem here, we have 4 to the -3rd power. So I would call this kind of a basic problem because we're just having to take the reciprocal. So go ahead and do that. So 1 over 4, and now it becomes a +3 because we flipped it. So 1 over 4 to the 3rd power. And since 3 is less than 5, we want to go ahead and simplify it. So we would turn that into 1 over 64. Okay, and again, I want you to leave it as a fraction, okay? Now we have some other problems here to get some practice with, and notice that they're all in different forms here. So I just wanted you to get a chance to see lots of different types of problems because you'll see those on your assignment today. So again, the first one kind of is that basic type of problem, and then some of them get a little more complex. I'm going to go ahead and just kind of go through them. If you want to pause and try to do them yourself first, that would be great. And then unpause, and then you can check it with me, okay? So in the first problem, like I said, again, it's kind of that basic concept. We know we have to flip it because it has a negative exponent. So I would put 1 and then x to the 9th there. When we flip it, the negative goes away in the exponent. Now, we do the same thing if the negative is in the denominator of the fraction. We still flip it, but now it becomes into the 3rd over 1. So you're flipping it, and we can just write that as into the 3rd power. Now this one here, remember you can break it apart into pieces. So the 4 is by itself. It doesn't have a negative exponent. Then you have c to the -3rd, and then the b is also by itself. So think of it as 3 pieces to that expression. So the 4 and the b, I don't have to do anything with those. So I'm just going to carry those down. But the c to the -3rd, I would have to flip it and move it to the bottom of the fraction. And when I do that, it becomes a positive 3. Okay. Here, again, think of this as 2 times 1 over a to the negative third. If I were to split that apart and rewrite it as a multiplication problem. So the 2 stays where it is, but the negative 3 is going to move to the top. So I would flip that, and the a to the third is now on the top with the 2. And you could think of this as 2 over 1 also, if that helps. Okay, so our final answer would just be 2a to the third. The last one here, again, think of this as 2 pieces. You have n to the negative fifth, think of that as over 1, times 1 over m squared. That's another way to write this problem, splitting it apart into its pieces. So I know I'm going to need to flip the n to the negative fifth to the bottom, but there's still a 1 there in the top. And so n to the fifth would flip down, but I also have m squared there already in the bottom, and then n to the fifth. I want to go ahead and write it so it's alphabetical also, keeping that in the correct order. So that's what our answer would look like there. So if you paused, obviously you want to check your answers, but you can see how to do each one there, and they're all, like I said, a little bit different forms. Now, we can also evaluate an expression. So I could look here at what is the value if we know n is negative 2 and we know w is 5. So I'm going to go ahead and rewrite it. So instead of n, I'm going to plug in negative 2, put that in parentheses, to the negative fourth power, times w is 5, so 5 to the 0 power. So that's what it looks like first when you've plugged in those values. And then the next part here, of course, is just simplifying it there. So 5 to the 0 is just going to become 1. And we don't usually have to write 1 there. If you want to, that's fine. But we know when we multiply by 1, it's just itself. So really, it kind of just goes away. We don't have to write it anymore. But if you want it there, that's fine. So let's think about, we have negative 2 to the negative fourth power. And I know I'm going to have to flip that. So there's going to be a 1 in the top. And then I have negative 2 to the to the positive fourth power now. And then since 4 is less than 5, I want to go ahead and work that out. And when you're plugging that in on your calculator, it is helpful with negative numbers that you put it in parentheses on your calculator before you take it to the fourth power. Because sometimes the calculator will give you an answer that is the wrong sign if you don't have parentheses around that, okay? So we would end up with 1/16 for our final answer there, okay? Then we're almost done here. We've got an example here where they want us again to plug in values for the exponent here in the word problem. So a population of insects. So we've got kind of a science question here. A population of insects is modeled by this expression where W is the number of weeks after the population was initially measured. So they want us to evaluate this expression when W is negative 2. So that would be 2 weeks previous to when they measured it. 0, which would be the current week. And when W is 1. So if we want to look at each of those, we would just plug in 3 to the negative 2 power. We would have 5,400 times 3 to the 0 power, and 5,400 times 3 to the first power. And then we would just evaluate each of those. Probably easier if we just evaluate those on the calculator. Makes it go a little quicker. So the first answer we should end up with is our population was 600. And remember, that means weeks previously, 2 weeks previously. When it's 0, it's just our current population, which is 5,400. And then here we're just basically multiplying by 3. So we would end up with 16,200. And that's insects. Not sure what kind of insect. Okay. So just evaluating that expression, getting a little practice using the calculator, all those good skills there that we're going to need for this chapter, okay? Now there is a lesson check here, and it's looking at finding the error. And remember that these types of error analysis questions usually go over an error that is common. So if we look here at the original problem, it looks like they did flip the a to the negative n. Looks like they flipped it up to the top, which is correct. The x to the n would stay where it is on the top of the fraction. But then they said b to the 0 is 0. And we know that's not correct. We know that any value, anything to the 0 power is always 1. So our correct answer should just be a to the n, x to the n power. And we could say over 1, but we don't need to, but you could. So basically the students said b to the 0 power is 0, which is not true, right? Okay, so there we have it. That's the end of our lesson, and next you need to check my website where I have posted the assignment for the day, and we will check it when I see you guys tomorrow, okay? So have a good day and get to work on that assignment. See you tomorrow.